Hello. I hope everybody's fine and doing well. And today, what's my target is basically the target is basically to make this mysterious connection. I mean, among all the mysterious science has faced, like dark matter, black holes, the birth of universe, no question is as intimate and I think perplexing as one hidden that is hidden inside the human skull. So the point is consciousness a quantum phenomenon? This is what's the motivation. This is what we have to try to understand. And this single question drives the entire exploration of quantum brain. Now, to understand its depth, what we should do is we must break it down. We must try to realize some of the important realms, the important domains. Now, why this question even exists is, I mean, if the brain were simply a classical machine, a classical mechanical machine, a network of electrical wires and chemical switches, then consciousness should be completely predictable. You should be able to predict every action. It should be purely mechanical in nature. And it should be fully explicable in the pure physical terms. But the point is that the consciousness is not mechanical in nature. I mean, it is rich, subjective, unified, and creative. It feels as though something more subtle is happening. Thoughts, let's take an example of thoughts. The thoughts arise without obvious cause. And ahead of the thoughts, what we have is we have decisions fluctuate. They fluctuate and then solidify. Emotions, talking about emotions. Emotions blend and separate like waves, not like switches. Don't behave like on and off switch, the logic of 0 and 1. And talking about dreams, dreams shift states, certainly, like quantum jumps, as if there are some quantum mechanical jumping going on. Conscious awareness feels singular, even though the brain is massively distributed. You feel as if you are working uniquely on some point of singularity at a time. So classical physics struggles to describe these qualities without leaving the major gaps, because there could be a variety of reasons for that. That's why scientists and philosophers are seeking whether the brain's deepest processes involve quantum rules, not just the classical ones, in which you have those electrical signals going on from one neuron to another neuron. So the point is that what makes quantum mechanics relevant here? What I believe is that quantum mechanics introduces principles that seem strangely aligned with the phenomenon of mind. They seem to have a kind of quantum mechanical trajectory. And the very first important thing is the superposition. Now, if we talk about the quantum mechanical particle, a particle can exist in multiple states at once. Similarly, the mind, if we talk about the mind often holds multiple possibilities before you make a decision. And there is another important argument in quantum mechanics, what's called as entanglement. You have two distant particles, they can share an instantaneous connection. And similarly, what I say is distant parts of the brain show coordinated, unified activity that classical physics, the classical signals cannot explain. And there is another important argument, and what's that? That's the collapse of the wave function. Now what we have, a quantum state collapses into one outcome when measured. Similarly, a human thought, if I talk about a human thought becomes decided only when the attention focuses on one option. But before that, there are multiple states, there are multiple thoughts that are going on in our mind. And then we have quantum coherence. And this is something that, like quantum systems, what do they do? They maintain internal harmony that allows complex, unified behavior. And similarly, consciousness behaves as a single unified experience. Despite billions of neurons are firing independently in all domains, in all networks. And these parallels do not prove quantum consciousness, but they motivate this question seriously. We're fully motivated by this argument, but it does not completely explain the whole argument. Now, the point is that what we have is the biological challenges here. So what biology is doing? The biology appears at first to be unfriendly to the quantum states. I mean, quantum coherence, usually what it needs, what it requires is you need extreme cold. You need isolation. You need low noise, and you need stability. So, in contrary to this, the brain is warm, it's wet, it's noisy, and it has chemicals and constantly active. Such an environment usually destroys the quantum states through what we call as decoherence. So we have a challenge here. So the challenge that we have is that how could the brain possibly preserve the quantum effects? As I said, as I talked about those important postulates that are important, and this is the biggest objection to the quantum brain theory. But when we see for the last 2 decades, these last 2 decades have flipped the discussion. Scientists have confirmed quantum effects inside the living systems. And what we have quantum mechanical tunneling that's happening in enzymes. We have quantum coherence, and quantum coherence becomes the only process in photosynthesis that you are able to transfer tremendous amount of energy from sun to the plants. Then we have quantum spin effects in the birds, and they allow the birds to navigate. And we have quantum vibrations in the smell. What am I trying to tell here is that life is not as classical as once we believed. This opens the possibility, still maybe controversial, but not absurd, that biology might use quantum processes at the deeper levels than what we have imagined, what we have thought previously. So another argument I would like to give here is that consciousness as a quantum information. Now, if consciousness turns out to be quantum, what's going to happen? Then the brain is not merely an electrical organ as it is believed in the framework of classical physics. It's a quantum information processor, and it carries information, it makes processes, and it's capable of generating these superposed states, the quantum jumps that you have from one idea to another idea, and the entanglement between the neural groups, which is impossible classically for a neuron far from another neuron. So what we have here, we have probabilistic decision making, and non-classical memory formation is there. We have global coherence giving rise to the self. So what's going on? This model is elegantly explaining the qualities of consciousness that classical neuroscience treats as mystery, or they may treat it as a magic that's going on outside the framework of classical physics. Now, for example, if I take an example, why you feel oneself, why you feel one, despite 100 billion neutrons, they have a coherence inside the brain, and why creative insights come all at once. That tells me something about the collapse of the wave function, and why thoughts mix. They keep on mixing. There are tremendous numbers of thoughts. They superpose, they blend, they superpose, and why emotions can be intertwined through entanglement. So the point is that it does not replace the classical science. The quantum approach does not replace it, but what it does, it adds a deeper layer beneath the understanding of the classical brain. Now, why this question leads us? By asking, is consciousness like we open doors to profound investigations? Now, what physics can tell about is that are quantum states present in neurons? Is it present there? And what biology can talk about is that can life sustain the coherence at high temperatures, in the warm conditions? And the neuroscience, what it can do is can neural patterns behave like quantum waves? And there is also the implication, the philosophical implications to this argument. And technology itself, can quantum AI models, can quantum AI model consciousness better than that a classical artificial intelligence can do? This is not just a science question. It's basically, it's a question about the nature of ourself, the nature, the perception, the choice, the existence that we have. So with this open question in our mind, this is an open question that's going on, and this is what I wanted to share with the fellow pupil regarding the quantum mechanics of brain, and how we can actually articulate the quantum mechanical nature of the brain. Even though I'm not a biologist, I'm not a neuroscientist, I'm a simple physicist, but certainly the things come from the very bottom. They come from atoms, molecules, electrons, protons. So where classical theories succeed and fail, we have where quantum effects might arise in the brain, and these things are going on. But as a physicist, what am I trying to tell is that at the bottom of all thoughts, what we have is we have an implication, because we theoretically model the actions of the quantum mechanical particles, and these actions seem to have the basic bones of the working of the brain, because no doubt the intermediate particles for the brain are neurons, but neurons are themselves made of the fundamental particles. They are made of the fundamental atoms and molecules, and we keep on calculating the wave function for these thoughts. Now, if I again talk about our thoughts are non-deterministic mechanical outputs. So mechanically, you cannot come up with that kind of argument. So with this, I would like to end, and I would like